Hi, today's topic is adjoint of a square matrix. Let's start with what is adjoint. After that, we'll start how, with the help of adjoint of a square matrix, we'll find out the inverse of the square matrix. Okay. So here it is given adjoint of a square matrix is nothing but the transpose of the cofactor matrix of the given matrix. So if you have AB a square matrix is given, AB a square matrix is given. Now adjoint of that square matrix A is denoted by ADJA, that is the full short form of adjoint of A. So A square matrix, all the elements here denoted by Aij, and here Cij are the cofactor of Aij, right? So as we know that for any square matrix we can find out for every element there must be one cofactor values. So this is very easy. Whenever any square matrix will be given, first for every element find out the cofactor of every element, then just remove the element in place of in the exact place, just put all the cofactor values like C11, C11, we know that C11 is the cofactor of A11. Similarly, C12 is the cofactor of A12. In this way, whenever you will get all the values of the cofactors from the element A11, A12, and so on, just remove all the elements. In place of that, just put the cofactor values. You will get new matrix, just that matrix denoted by B, and adjoint of the original matrix A is nothing but the transpose of that cofactor matrix. We called it as cofactor matrix whenever we are replacing the original element and we are putting the values of the cofactor in place of the element value. So that new matrix formed known as the cofactor matrix, and adjoint of the original matrix is nothing but the transpose of the cofactor matrix. So how it works? So here I have written one square matrix of order 3 cross 3 A. The elements are A11, A12, A13, A21, A22, A23, A31, A32, A33, right? Here I have written the cofactor matrix. Clear? This is the cofactor matrix I have written, right? What is the cofactor matrix? Here, cofactor of A11 is C11. Similarly, cofactor of A12 is C12. Cofactor of A13 is C13. Similarly, in this way, for example, cofactor of A32 is C32. So whenever we'll get the value, all the cofactor values from the element, as we know that how to find out the cofactors from minor and then -1 to the power I plus j into the minor, right? So you'll get the cofactor values. In the previous class, we have already discussed about the minor and cofactors. So whenever you will get the cofactor values, just put in place of the element. Now, what will be your next step? So this is your cofactor matrix B. Now, adjoint of A is nothing but B transpose. So ignore that part. Directly you can write this one, C11, C12, C13, C21, C22, C23, C31, C32, C33, whole transpose, right? So which is nothing but your C11, just transpose it, C21, C31, C12, C22, C22, C23, and similarly C13, C23, C33. So this is your cofactor matrix. After transpose of the cofactor matrix, you'll get this value, and this is your adjoint matrix. So we can say that adjoint is also, adjoint of any matrix is also one kind of matrix form. So the given matrix A, it should be square matrix. This is possible only for the case of square matrix. Whenever any square matrix will be given, this is already in a form, and adjoint of that matrix is the another form with the help of cofactor values. Okay, in that sum, this is given, one matrix 3 cross 3 order matrix is given. We have to find out the adjoint of A. The matrix is 3 cross 3 given square matrix. Elements are 1, 1, 1, 2, 1 minus 3, and minus 1, 2, 3. We have to find out the adjoint of that matrix. How will you? So first you have to find out the cofactor values of every element. So first element A11, this one is A11. A11 is nothing but 1. Similarly, A12 value is 1. Similarly, we can proceed. A32 is this one, 2. So every values must have some cofactor values. So just quickly find out the cofactors of all the elements. Okay, I have written the structure, but these are not the cofactor values. First, here I have written, if we know that I plus j is even, then no difference of the minor value and cofactor values. If I plus j value is odd, then the cofactor value is just opposite value, just sign interchange value of the minor value. So first, here I have written all the minor values first. This is the minor values, this is minor value I have written. This one M11, this is M12, this is M13, same as this is M21, M22, M23, M31, M32, M33. These are not the cofactor values. I have first determined only the minor values. Now check, 1 plus 1 is even, so the cofactor value will be same. 1 plus 2, this is odd, I'm writing odd, so here one minus sign will come, as because we know that minus 1 whole to the power 1 plus 2 equals to minus 1, right? So minus one minus value will come in front of that. Now C in C13, 1 plus 3 even, no change. Now come to C21, that is odd, so one minus value will come. Now for C22, this is even, so no change, it will remain same. Here please correct, this is minus 3. C23 is 2 plus 3, 5, that is odd, so 1 minus sign will come, so it will be minus value. Here also it will be -1. Now come in that row C31, that is 3 plus 1, even, so it will be like this. Now 3 plus 2, 5, so 1 minus sign will come here and 1 minus sign will also come here, the value will be +5. 3 plus 3 even, so it will be like this. So our new cofactor matrix, so we can directly write, just take all the cofactor values and just transpose it, and you can directly write the adjoint, and you can find the adjoint of the original square matrix. How it will be? So adjoint of that matrix, just put the cofactor values first. It is 9 minus 3, 5, -1, 4, -3, -4, +5. This is not minus, this is equals to sign, and this is -1. Just write the transpose of it. You will get the value 9 -1 -4, then -3, 4, 5, then 5, -3, -1. Right? So please check once again. 9 -1, 4. I've written 9 -1, 4, -3, 4, 5, -3, 4, 5, 5 -3 -1, 5 -3 -1. So our new matrix, which is known as the adjoint of the matrix, adjoint of matrix A, is 9 -1 -4 -3 4 5 5 -3, this is 5 5 -3 -1, and here it will be your answer. So this is how we have to find out the adjoint of any given matrix. There is one shortcut trick you can also follow for any 2 cross 2 order. This is the shortcut trick I'm writing. For any, suppose for example, any 2 cross 2 order matrix, this is only applicable. This is only applicable for the case of 2 cross 2 order. This is directly, you can use it in JEE also. So here, suppose any 2 cross 2 order square matrix is given 2, 4, -5, 7. So your matrix is given B. So how will you find out adjoint of B? Just there is one shortcut trick I'm telling you. First follow this diagonal, interchange, first interchange the element without exchange or interchange, or better to say without change of, sign. So first I'm writing 7 and this will be our 2, right? Now I'm write it in the different color. Now follow this diagonal, these 2 elements, just don't exchange the place for these 2 elements, don't exchange, or better to write, interchange the place, only sign will be opposite. Right? So what you can write here, this is -5, so just write 5. Here this is 4, so it will be -4. Only the sign will be changed, no such change of or the interchange of the place, only sign will get reversed. And for this case, only without exchange or without change of the sign, only these diagonal elements will be interchanged. So this is how you have to find out. You can use the shortcut trick. This is shortcut trick. You can apply it in JEE also.